You just watched a few videos about the atomic structure. Let's write everything down that is important so we can remember it for future use. So the parts of the atom are the protons, neutrons, and electrons. Their symbol would be a P for proton with a plus charge because they're positive. Neutron, sometimes you put a 0 for 0 charge because it's neutral. And electrons have a negative charge. So the relative charges are positive 1, 0, and negative 1. Okay. Sometimes I just write proton. Sometimes I just write positive. They all mean the same thing. Sometimes I just write N for neutron, or an electron, or a minus. They all mean the same thing. So they are very light. For example, a proton weighs 1.67 times 10 to the negative 24 grams. The neutron has the same mass, very similar mass to the proton, negative 24 grams. And the electron weighs about 10,000 times lighter. So it's about 9.11 times 10 to the negative 28 grams. The way I know it's 10,000 times is because negative 24 and negative 28, that's 4 powers of 10, so 10,000 times lighter. Okay, so it's obvious that if we want to talk about the mass of a proton, we do not want to keep writing this number over and over again because it's too much to write. So to be efficient, we're going to call this number, which is negative 1.67 e negative 24. This is pretty close, 1.66 e negative 24, to be 1 AMU. So these two numbers are pretty much the same number. AMU stands for atomic mass units. So instead of writing all this, we just say, oh, that's 1 AMU. A neutron is 1 AMU. And since an electron is 10,000 times smaller, it's 0.0005 AMU. It's pretty much 0 AMU compared to the protons and the neutrons. So now you understand what the mass is of the atom. Let's look at our periodic table briefly. So the periodic table that you will be using is in webelements.com. The periodic table is arranged by atoms by the number of protons. So the very first element you see is hydrogen. It is very different from helium because of the number of protons. Hydrogen, this number right here, number 1, is the number of protons. Okay, so helium has, yes, you're right, 2 protons. So the first number is called the atomic number because it identifies the atom. It is also the number of protons. The number underneath the element symbol is the mass number, okay, which is composed of the mass of the protons and the neutrons. So you might wonder, where's the mass of the electrons? Well, the mass of the electrons are incorporated but since they are 0 AMU, it is not really, it's hardly there, so you don't have to write it in the mass. The next thing we're going to talk about are isotopes. Let me show you some images of the hydrogen atom. So the hydrogen atom, when we look at the periodic table, we can see that it has 1 proton right there, the number 1. So if I were to draw that, I would signify the proton in the middle, and that would be a hydrogen atom. I'm not going to draw the electron right now because it's going to get in the way. There's not much room. So the second one right here is also a hydrogen atom because it has 1 proton. Okay. This third one, if you can guess, what atom is this? Yes, since it has 1 proton, it's also hydrogen. But these 3 hydrogen atoms are very different. The first hydrogen atom does not have any neutrons. The second one has 1 neutron in the nucleus, and the third one has 2 neutrons. So as you can see, These are all hydrogen atoms. They all do exist on Earth, but they're very different. The difference is they have different number of neutrons and they have different mass. These three atoms are called isotopes of hydrogen. Okay, so go ahead and tell me, what are isotopes in your own words? Will you please pause the video and write some things down that you notice about these three isotopes of hydrogen? What's the same? What's different? Go ahead and write that down. So, did you write the following? Did you mention that all these are the same elements? They are all the element hydrogen. Also, they all have the same number of protons. One proton, one proton, one proton. They have different number of neutrons. 0 neutrons, 1 and 2. They have different mass. The mass of this isotope is 1. The mass of this is 2 AMU. And the mass of this is 3 AMU. So you might wonder, well, how are we going to communicate to the public what isotope we are speaking of? So we have different notations. The first one is called the AZ notation. In this notation, Z stands for the atomic number. Or the number of protons. And the A stands for the mass. And it looks like this. So you put the element symbol in the middle. Let's say it's hydrogen for this one. Then you put the A on top, left-hand corner, and then the Z on the bottom left-hand corner. Okay, so again, this is the element symbol. This is the mass number. And as you notice, it's equal to the number of protons and neutrons. And this is the atomic number, which is also the number of protons. Okay, so let me give you the AZ notation of the first hydrogen. So the first hydrogen only has one proton, right? So the AZ notation would be H. The mass is 1 because it has only one particle in the nucleus, and the number of protons is also 1. This is the AZ notation for the first isotope of hydrogen. Could you please go ahead and draw the second and the third isotopes in their AZ notation? Pause the video. So you have, they're both hydrogens. All these isotopes are of hydrogen. The mass for this one is 1, 2. There are 2 particles in the nucleus, and it has 1 proton. Okay, this one is 3. 1, 2, 3, that's the mass, and 1 proton. This is called the AZ notation. Another notation that you should be aware of is called isotopic notation. In this notation, you write the element symbol. Sometimes it's written out hydrogen with a dash, not a negative, just a dash, and the mass number. And not a subscript or superscript, a big number. Okay, so this would be isotope H2, and this would be, you guessed it, hydrogen dash 3, not negative 3. So the atomic mass unit, AMU, is defined as the mass of an atom where 1 AMU is 1/12 of a carbon-12 isotope. So which means this carbon-12 has a mass of 12. Divide that by 12, you will get 1 AMU, and that's where it was defined from. Okay, so let's practice drawing some atoms given the AZ notation. So if this is lithium, and the number underneath is 3, that means it has 3 protons. So you would draw 3 protons. I would just draw that because I don't want to draw 3 circles. It would be hard to read. Then the mass is 7. So this is protons. So the 7 would be the protons and the neutrons. Therefore, 7 minus 3, there will be 4 neutrons. Electrons are on the outside. Because this atom is neutral, and you can tell it's neutral because there's nothing on the top right-hand corner, that means it's 0. You have to have equal number of protons and electrons. Therefore, this has 3 electrons. And that is a neutral lithium isotope. Okay? Let's go ahead and try using this notation. In this notation, it is the isotopic notation where the 9 is the mass. Therefore, I have to figure out what is the atomic number. To do that, you have to go to the periodic table. So you look at beryllium. Beryllium is right here. And as you can see, the number 4 right there, that is the number of protons. So I will write beryllium has 4 protons. P pluses. Okay. This number 9 is the mass, which is the number of protons plus neutrons. Therefore, if they all have to add up to 9, that means I have 5 neutrons. To make this neutral, so the 9 matches what's in the nucleus. The electrons won't hardly weigh anything, but it needs to make this atom neutral, so I need 4 electrons to match the 4 protons. So you watched a video regarding ions. Lithium plus 1 is an ion, and beryllium minus 1 is also an ion. Okay, positive ions are called cat ions because cats are good, and negative ions are called anion because ants are bad. So that's a mnemonic to remember. So to draw this lithium ion, I would first look at the periodic table and look at the number of protons. Looking at the periodic table, lithium is right here, and zoom, there are 3 protons right there. So I will draw 3 protons. Okay. If they're not asking for a specific isotope like the one above, you would have to look at the number here. The 6.94, that's the mass, and you have to round it to the nearest whole number. Make that 7. So the mass is 7, that means I would need 4 neutrons. So if I were to draw an AZ notation of this, it would look like this. It would be lithium with a 7 as the mass and 3 as the protons. Okay? If this lithium were neutral, it would have 3 electrons. But because this is positive, that means there are more protons in it, right? Because protons are positive. But you cannot add a proton in the middle because that would now change lithium to a different element. It would now be beryllium, but you want to keep it lithium. So in an ordinary chemical reactions, all we're doing is removing electrons or putting electrons in. In this case, we are going to remove 1 electron going out, which leaves us with 2 electrons. Okay, so now 3 positive, 2 negative equals 1 positive, and that's where the positive ion comes from. Positive ion comes from. Okay, so lithium plus 1 has 3 protons, 4 neutrons, and 2 electrons. Please pause the video and try beryllium minus 1. Okay, so the first thing I did was I looked at the periodic table and I found that beryllium has 4 protons, and sorry, you can hardly see it, that's 4, and then it has a mass of 9. So I'm going to go ahead and draw the AZ notation, 9 up here, 4 down here. Then I'm going to draw the nucleus. You have 4 protons and 5 neutrons. Then you count the electrons. If it were neutral, it would have 4 electrons to match the protons, right? 4 and 4. But because it's negative, that means 1 electron came in. So you add 1 electron coming in here. Now you have 5 electrons. So as you can see, you have more negatives than positives, so the charge will be -1. You can write the AZ notation like this, if you wanted, with a -1 on the top right-hand corner. Okay, so if you see a positive ion, you are going to remove electrons. Do not ever touch the nucleus because the nucleus has energy within it, too much energy, and we cannot remove that in an ordinary chemical reaction. Please pause the video and do the last two problems. Okay, so I did lithium right here. Same AZ notation as above, but this one has a +1 charge, this one has a -1 charge, so the nucleus is the same, 3 plus and 4 neutrons. The only difference is the number of electrons. It's negative, therefore an electron came in, so instead of having 3 electrons, you would have 4 electrons. Okay, the boron I had to look up right here. It has 5 protons and the mass is 11. So you round that number to 11. So we're going to write 11 here and 5 down here. The charge is +1. Therefore, I'm going to write 5 protons, 6 neutrons, adding up to 11. Then the electrons is normally 5 electrons, but because it has a +1 charge, that means 1 electron left. So now instead of having 5 electrons, it has 4 electrons. So you have more protons than electrons, so you have a positive charge.